So our physics project covers using ideas of energy to predict motion. Just to give a little introduction to the experiment, our experiment covers concepts of potential and kinetic energy, and with this we are bouncing a volleyball. Basically what we did was we bounced this volleyball, and we wanted to use these concepts of potential and kinetic energy to predict the height of the ball, which we could then compare to the experimental height, which is determined from the video analyzing software. By determining the velocity right after the bounce, which we also could find with the video analyzing software, we would be able to find the maximum predicted height using energy equations. Just to give a little background on what potential and kinetic energy actually is, as you can see in the diagram, the potential energy is when the biker's at the top of the mountain. So it's the energy that is available, and then the kinetic energy is what the potential energy is transferred to when motion occurs. So you can see in the diagram, when the biker is going up the mountain or down the mountain, there's an energy output in the form of a velocity, which is motion. As you can see in the kinetic energy equation, velocity is a factor in it. So this potential energy is transferred to the kinetic energy when the motion occurs. So here we'll play the video of the volleyball bouncing, and then we'll analyze and look at the results after.
Go.
So as you can see, we did a velocity versus time graph, and we pinpointed the point of the velocity right after the initial bounce, and you can tell that it is 4.00 meters per second. So what we did was, to find the bounce height, we basically took the potential energy equation, which is mg delta y, and we set that equal to the kinetic energy equation, which is 1/2 mv squared. And the reason for this is the potential energy should be equal to the kinetic energy if we find the velocity right after the bounce. Through solving for delta y, we were able to cancel out the mass and get the equation v squared over 2g. And when we plugged in our velocity of 4 and plugged in the gravity of 9.8, we got that the delta y was equal to 0.816 meters. After that, we did a position versus time graph, and as you can tell, we marked the point of the final bounce height, which is at the end of the graph, which turns out to be 0.810 meters. So you can see that the predicted height of 0.816 meters was very close to the experimental height of 0.810 meters. So this shows that you're able to use these concepts of potential and kinetic energy and set them equal to each other to predict the height, as long as you know the velocity after the bounce. And the reason for this is the velocity can be plugged into the kinetic energy equation, and since the mass of the volleyball stays constant and there's no change, you can just set that equal to the equation for the potential energy.